Okay, guys, so we're actually going to come down to these proofs, okay? And I know it's been a little bit of time since we've done proofs, but I think that it'll be good because I'm going to be kind of guiding you guys through them step by step, okay? So here's what I want you guys to do. All right, we're actually going to start here on proof number 2, okay? And I want you guys to take a second and write out that given, okay? All right, I'm going to write given. And since I'm not with you guys, I'm assuming that's what most people are going to do. All right, we're just going to write out given. Okay. All right, so let's just take a second and look at what we're trying to prove. All right, what we're trying to prove here is that this WS, all right, has to be greater than this WQ, okay? That those two sides have to be greater. So let's go ahead and look at our given, and let's see how we can build off of it. So we are given that, it's all marked on our picture, all right, that we have segments that are congruent to one another, okay? We're given that SRV is greater than QRT, and we're given that R is the midpoint of SQ. Where I would probably start, all right, is probably where we're most comfortable at, which is that R is the midpoint of SQ. So my second step here is going to be that SR is congruent to RQ, and that's through midpoint theorem. Okay, so it's actually pretty important that we start there because if you remember the hinge theorems, all right, that we just went over, it's always dependent on having at least two sets of congruent sides, okay? So we're then given, all right, what I want you guys to focus on is this step right here, is that SRV is greater than angle QRT. So I use greater and less, okay? So what that means is if this angle of SRV is greater than this angle of QRT, what does that mean about SV and QT? Well, using the hinge theorem, all right, I know then that that side length of SV has to be greater than that side length of QT. So that's through the hinge theorem. Okay, so let's just break this down real quick. All right, let's just see why this makes sense to us. So we just said that this side length of SV has to be greater than this side length of QT, right? So let's just put some numbers in there just so that we can visualize, okay? So let's say that this was 5, and let's say that this is 3, okay? And VW and TW are congruent, so that means that they have to have the same side length, which means that this is 2, and that also has to be 2, okay? So remember what we're trying to prove is that this full side length of WS has to be greater than this full side length of WQ. And that should make sense to us because if we're adding the same thing, 2 and 2, all right, to two different numbers, the one that starts off greater has to remain greater, all right, than the one that starts off smaller. So this side length would be 7 and this side length would be 5, right? Now, we can't do it using numbers, but we can do it using our handy dandy theorems, all right, of the fact of our best friend, which is segment addition, okay? So before I do that, though, I'm going to do a step, all right, where I'm going to do some definition of congruence, okay? So I'm going to state VW is equal, all right, to, how do they have it? The VW is congruent to TV, okay? So that's coming up here. I know I switched the orders, but it should be fine. Oh, TW. All right, so that's going to be definition of congruence. And then I'm going to go back to our best friend, and I'm going to do some segment addition. So I'm going to do WV plus VS equals WS. And I'm going to have WT plus TQ equals WQ. And that's through segment addition. Okay. All right, so here's what I want you guys to do real quick. All right, I'm going to have you guys switch the order of this just so that it's a little bit easier for us to see. Let's change that to WV is equal to WT. I think it'll just be easier for us whenever we are doing these questions, okay? So here's what I want us to look at, guys, all right? I want us to look at step 3, all right, which says that SV is greater than QT. And I'm going to keep that greater, all right? So I'm going to do SV is greater than, all right, QT. But what I'm going to do is I'm going to take this step 4 and I'm going to add, all right, WV, all right, to this side right here. And I'm going to add WT to this side right here. And that's going to be allowed because I'm adding the same things to both sides. And I'm going to be using the addition property, okay? So I'm going to add WV right here. And I'm going to add WT right here. So this step 6 is through addition. Okay. So the reason why we're doing that is I now want us to look at step 5 and step 6. All right. Take a look at what we just created. WV plus VS. All right. VS, WV, isn't that equal to WS? So couldn't I take that WS and plug it in, all right, for that left-hand side? So I'm going to have WS is greater than, all right, take a look at this one. All right, WT, WT, TQ, TQ. I'm going to take WQ, plug it in on this side. So I'm going to have WQ. And that's through substitution. And that, ladies and gentlemen, is what we're trying to prove. All right. If you look at what we're trying to prove that WS is greater than WQ, which is what I have right there. Okay. All right. We're going to do one more. It's actually a really quick proof. Okay. But we have to draw a picture for it first. Okay. So here's what I want you guys to do. I want us to start by drawing a triangle. And you're just going to have to kind of follow along and make sure yours looks kind of like mine. And we're going to call that R, S, and then T. And then we're going to take a segment that's coming out of S so that it looks kind of like that. I mean, it's good enough. And that's Q. Okay. We're going to call this angle 1, and we're going to call this angle 2. And then what I want you guys to do is I want you to write out your given. And this time I'm going to write it out. All right, so RQ is congruent to ST. And that's through given. All right. So it's going to be a really quick proof, guys. And we're going to mark that, even though it's not drawn to scale, all right, that RQ is congruent to ST. And that does not look like we have much to go off of, correct? So let's see what we're trying to prove, all right? What we're trying to prove is that this side of RS is greater than this side here of QT, okay? And so if we just kind of think about what is our game plan, all right? Wouldn't it be a good game plan to say that, well, if I could prove that angle 1 is greater than angle 2, wouldn't that be enough to then say, if we're looking at our opposite sides, all right, that proven statement is true, okay? But in order for us to do that, don't we need to always start with at least 2 sides that are congruent? So if you look at our picture, we have one set of sides that are congruent, all right, how are we going to get our second side? And that's going to be through the reflexive property to state that QS is congruent to QS. So that's through reflexive. All right. Now, this is actually only a 4-step proof. And I'm going to tell you guys that what our next step is it's actually our game plan, is that angle 1 is greater than angle 2. And if we were in class, I always love to wait and see if people can figure out why. And unfortunately, we're not in class. So what I want to do is I kind of want to guide you guys real quick. All right, I'm going to get rid of my highlighting. All right, and I just want you guys to kind of look at what I'm highlighting real quick. So I'm highlighting this right here. So it stems back to yesterday's lesson, all right? And so I want you to look at angle 1, and I want you to look at the triangle that I highlighted, which is QST. And isn't angle 1 an exterior angle to that triangle? And then isn't angle 2 a remote interior angle? And so what we discovered the other day was that this angle 1 has to be greater than this angle 2 because the exterior angle inequality theorem. It always takes students a second to be able to catch on to that. So if you didn't see it right away, that's fine. All right, but it should make sense now. So then now, once we've hit that angle 1 is greater than angle 2, we can actually go to what we're trying to prove, which is that RS is greater than TQ. And that is, once again, going to be through the hinge theorem. And that's it, guys. All right. Hopefully those made sense to you. Okay. They're two of my favorite proofs of the year, so I'm sad we couldn't do them in person. I do think that this section up here where you're finding the range of numbers is going to be one of the harder parts. All right. So if you have questions on that, let me know in your homework. Okay. That's it. Good luck.